Hello, everyone, and thank you so much for being here today at my debut Big Data London speech. Let's go. My name is Azan Khan. I'm a data protection SME for Now Pensions. My contact details are over there if you want to get in touch with me afterwards, because I forgot to put it at the last slide. So please do, if you are interested, take it down now, and that's my name on LinkedIn as well. Before I get started, quick show of hands. Has anyone here seen Oppenheimer? That's great, because I'm going to be covering two distinct topics in parallel. If you've seen the movie Oppenheimer, they also have two distinct timelines that ultimately have a larger point. And I want to talk very broadly about data anonymization, but also very specifically about this project that a number of pensions providers in the industry have been involved with, which is the Pensions Data Project. But before anything else, context. Sharing is an inherent purpose of data. It's quite obvious, and we see a lot of these headlines that data is the new oil, data is the new gold, you need to enhance and capture the value of your data. But something that surprised me when I was actually doing research for this topic is how much more beneficial it is to share data across industries, across different sectors. In fact, research by the OECD has pointed out some very interesting statistics, namely that the inherent value of data sharing in the economy, if you take both the public and the private sector, is anywhere between 1 to 2.5% of a nation's GDP, which if you want to contextualize to the United Kingdom, it's about 31 billion to 75 billion pounds per year. And what's even more surprising is the fact that relative to an organization taking advantage of the data that they hold, there's a 10-fold to a 20-fold benefit of actually sharing that data more broadly. And we see some pretty obvious examples of how data sharing can be very beneficial. For example, in Oppenheimer, we have the Manhattan Project, where we have the two Belois project of sharing data between the United Kingdom and the United States. We've seen the benefits of data sharing when it comes to fighting disease, COVID obviously being in very recent memory. And we also see it in other areas like enhancing efficiency for public transport, or in the case of the pensions industry, the discovery of lost pensions pots through something called a pensions dashboard, which is a completely separate initiative, but nonetheless is a data sharing project, or offering off tailored services similar to open banking. So the general spillover benefits of data reuse that could not have been foreseen is what contributes to the value of sharing the data. But alongside sharing data, there's an inherent purpose of protecting it. There is a limitation to data, which is that there is sensitivity that's attached to it. The data of individuals, for example, for healthcare data, is very, very sensitive, and most individuals obviously would not appreciate it if that was shared quite openly. And we're seeing a massive shift in consumer preferences towards privacy. A study by IBM and Harris Poll found that 84% of individuals think about whether they trust a company to keep their data safe before they buy from them or they engage from them. 76% think it's important to have the ability to opt out of sharing with third parties. And if you think about more general issues with data protection, you think about data breaches and so on, they are very, very costly to remediate. And increasingly, we are seeing cybersecurity issues faced by organizations in the UK and more broadly on a regular basis. It's quite easy for us to forget. And there's a quote that I think is attributed to Stalin, which is that the death of one is a tragedy, but the death of millions is a statistic. When we work with big data, it's very easy for us to forget that each row, each record actually deals with a living, breathing human being. And I think it's very important to keep that in mind. So given these two aspects of data, what approaches exist for reconciling the two of them? Well, we have legal approaches. For example, in the GDPR, there's an explicit understanding and aim that is to facilitate the free flow of data, but also enhance the user's control over their data. And there's a very good example that is very relevant for the Pensions Data Project, which is that personal data, if it's used for research purposes alongside the original purpose, that is in many situations compatible as long as you have appropriate safeguards that you use. And this is in Articles 5.1 and 89.1 as well. So what are these safeguards? Well, we have technological mechanisms to enhance the privacy of the data that we hold. The first one is privacy-enhancing technologies, which are commonly known as PETs. And there are a number of very interesting examples that are very, very novel and have, at the present moment at least, limited application because of the fact that they are very computationally expensive or the fact that they have very limited use cases. An interesting example is homomorphic encryption, which allows you to conduct analysis on data that is encrypted. So if you're going to be sending data to a recipient, the recipient doesn't actually know what the data is, but they're still capable of conducting analysis on it. And that's a very simple diagram that showcases that you encrypt the data first, you send it to a third-party provider, and they conduct their analysis and send you their analysis in an encrypted format that you're then able to decrypt. And there are many different examples of different case studies that do use these techniques. One interesting one from the Royal United Services Institute, which is a think tank for defense in the UK. They came up with a paper called Future of Financial Intelligence Sharing, which I highly recommend, where they have 8 different case studies of financial organizations like Western Union or SWIFT that use these novel techniques to interesting degrees of success, sometimes with synthetic data, sometimes live tests with actual data. There's also a very interesting guide from the Center for Data Ethics and Innovation called the PETS Adoption Guide, which is very funnily named, that I also recommend checking out because they also have many different use cases for these privacy-enhancing technologies, but also, more importantly, when it might be appropriate to use them. On top of the more novel techniques that exist, we also have traditional cryptographic tools like encryption and hashing. On top of these privacy-enhancing technologies, we have this fundamental paradigm of data anonymization because data that's considered anonymous moves outside the scope of the GDPR. So a lot of the compliance obligations that you have if you're working with personally identifiable data, you move past that by anonymizing your data. So I think it's time now to introduce the Pensions Data Project since I've been talking quite a lot about it. Most people start off with the question of what is it and why is it relevant? Why should I care about it? The Pensions Data Project is a government-backed data amalgamation project using real data for individuals in the UK who are saving or who have saved into a pension. And the reason why this data project came into being is because individuals who had moved across different jobs or moved across different industries and worked with employers who had different pensions providers ultimately ended up having small, tiny little pension pots across different organizations and didn't really know how much they held in those pots or where, in fact, those pots were, drawing back to the previous example of the pensions dashboard to help people find those pension pots in the first place. So these are the organizations that have been involved since the inception of the project. Mine is right there, which is Now Pensions. But we've joined up with 4 other pensions providers as well, Legal & General, Nest, People's Partnership, Smart Pension, and also the Pensions Policy Institute, which is an organization and think tank dedicated towards, as you guessed in the name, pensions policy. So the first question that you usually get when you have an industry-wide data sharing initiative, and that too the first of its kind in the pension space, is, well, we need to iron out the logistics of it. We need to think about how are we going to share the data, what are the barriers that exist to sharing the data. And the Pensions Data Project is actually very interesting because it has very unique context, complex context. Each of the providers had different lawful bases under the GDPR to process and share the data, or not in one of the cases where they weren't actually allowed to do that. Nest, for example, is a quasi-public sector organization, so they had their basis down in law, but other organizations, for example, like mine, we had different legal bases to share and process personal data. On top of that, each of the providers had different technology stacks. For example, Nest, which has been around for a long, long time, is using very legacy enterprise architecture, whereas at Now Pensions, we're currently undergoing a major digital transformation initiative. So each organization is at different levels of their digital journey. On top of that, the procurement of new privacy-enhancing technology solutions wasn't necessarily feasible due to budgetary, time, and implementation constraints. So when you're working within these constraints, how do you go about sharing the data? Well, it clicked, and that's why we're talking about this today, anonymity and anonymization. But how do we anonymize the data? And that's when the first major issue came. Do we anonymize by simply hashing the personally identifiable information fields and share those files? For those who may not know, hashing is a function that allows you to take any data of an arbitrary size and condense it down to a really, really small string of fixed length. And it looks like a series of random numbers and letters. And it's very, very good. It's very useful as an obfuscation technique, and it's not reversible, which is the best part about it. If you see a random bit of gibberish as a hash, you wouldn't necessarily be able to tell what the data that went into that was. So it's a good pseudonymization technique, but it's only effective if you're not having a unpredictable input space. What I mean by that is, if you don't really have any constraints on what kinds of data you're going to be hashing, then it's actually very good. But in this case, for example, if I just showed you this hash, you wouldn't really know what that is. But if we, for example, are trying to match data, and we know that the data belongs to, for example, a name or a national insurance number or a date of birth, they follow some pretty predefined patterns. If you knew that this hash pertained to a national insurance number, for example, you know that every national insurance number has 2 letters, then 6 numbers, and then another letter, and there are some additional constraints, but we won't really get into that. And the issue is that hashing is very computationally cheap to do. It's very easy to quickly generate a hash because that's done by design. And so what effectively can be done is you can brute force all existing hashes and then find a match for that particular hash. So in this case, if you're interested, it's QQ123456C. With modern technology, this can actually be done in less than an hour. There are only 17.5 billion possible national insurance numbers, and with the average hash rate of a computer being over 1 million hashes per second, it's very, very cheap to do. And if you know that the data pertains to, for example, a surname, you can actually look up common surnames on an open electoral register, and then all of a sudden the data set is no longer sufficiently anonymous. And this is a very big problem. Security through obscurity is not a good idea. And this paints a broader picture because this is not the first time that this has happened. Anonymization is actually really, really difficult to do correctly. There are many different examples, and we see all of these different news articles showing us where individuals that thought a data set was sufficiently anonymous turned out to not be the case. The example that I gave previously about national insurance numbers was very much similar to the New York taxi details issue because in that situation, there was a Freedom of Information request that led to about 173 million individual rides being shared. And the data that was meant to link that ride to a particular taxi driver was hashed using their license number and their medallion number, which follows a very predefined method, very similar to national insurance numbers. So they were able to de-anonymize the complete data set and then from that infer how much those taxi drivers had earned and where they actually live. In another situation, hands up if anyone knows the Netflix data anonymization debacle. Few people there. I'm raising my hand as if I know, but that was 2008 and I was 11, so I don't really remember. But that involved another very interesting data set of 500,000 individuals whose, I think it was watch histories and their preferences of those watch histories being shared. And Netflix said that if you were able to use this data to generate, or come up with a better recommendation algorithm, we'll give you a prize for that. So it was called a Netflix prize data set. And 2 researchers from the University of Texas at Austin ended up de-anonymizing the entire data set. And the individuals in the crowd, can you tell me how they de-anonymized it, if you know? IMDb, exactly. So it turns out that individuals who watch on Netflix and have certain preferences on Netflix end up putting those preferences in public databases as well, like IMDb. So they were able to find out the preferences and tastes of individuals, not only of movies, but also, for example, sexual orientation, based on the movies that they were watching and their political opinions. So it's very difficult to do anonymity correctly. Simply obfuscating or removing personally identifiable information is not enough. And I think the quote that I've linked from an opinion on anonymization techniques from the Article 29 Working Party, which is the precursor to the European Data Protection Board, is actually very telling. And it says an effective anonymization solution prevents all parties not only from singling out individuals, but also from linking records between 2 data sets. And that's, I think, where most individuals end up dropping the ball. They don't realize that anonymity is not something that exists in isolation. Anonymity is very contextual. The threshold in the Article 29 Working Party's paper was so high that even they themselves thought that anonymity wasn't really possible. And that leads us to the main point I'm trying to make in this presentation, which is that anonymity should not be considered in isolation. It should be contextually understood. You need to look at not only your own data set, but other areas where individuals can get additional data that could potentially de-anonymize your data sets. And there are tensions in this understanding of anonymization, but thankfully we have received some draft guidance from the Information Commissioner's Office on anonymity techniques and anonymization. In particular, this diagram is from Chapter 2, which I think is very instructive. It talks about different areas and different ways that you can consider contextual anonymity. You consider, for example, the motivated intruder. If a person was motivated enough to actually de-anonymize your data set using legal means, how would they be able to do that? On top of that, you also need to consider the broader context of your processing activities. Who is actually going to be receiving this data? Are you going to be, for example, publicizing the data set as Netflix did, or are you going to be sharing it, for example, in very limited contexts? That's one thing I wanted to draw to your attention. The second thing is a very interesting quote from the Spanish Data Protection Authority on the use of keyed hashes. Keyed hashes are effectively the same thing as hashes, except, as in the name, they have a key that allows for additional security that is only known by the individual or individuals who generate that key. So it has the same properties of being able to have that one-to-one relationship from a data of arbitrary size towards a fixed string, but it won't necessarily match all of the other public, hashing functions that exist. So given these two points and this understanding of anonymization, how did we at the Pensions Data Project solve the issue of data sharing? Well, what we did is we basically came together to generate a shared key for those keyed hashes. So without any outsider knowledge, we generated that key. Then we generated keyed hashes of all of the personally identifiable information data fields, and we selected the personal data in such a way that it allowed for a broader set, and you wouldn't be able to single out individuals simply because there's only one person in the Shetland Islands who actually has a pension at Now Pensions for that reason. There's also generalization that we use, so postcode shortening is one good one. Instead of the full postcode, you only use the first half of it, and for age, you can just use age ranges instead of the actual age of the individual. So there are numerous techniques that we applied to make sure that the data was sufficiently generalized and that any fields that we needed to use for matching of the data amongst different providers, we were able to do that without anyone else's knowledge, including our own. We then securely and verifiably deleted the very key that we used to generate the keyed hashes. So if we, for example, were to come across anyone else's file for whatever reason, we wouldn't be able to identify those individuals in the data set, which obviously would be a big concern, not only from a privacy point of view, but also from a commercial sensitivity point of view. We wouldn't want to share our data with other providers or intermediaries if they were able to de-anonymize the data set and understand what our books effectively looked like. Then, because we're working with consultants to try to analyze the data, the consultancy that we worked with generated different sets of public keys using a tool called GPG for Win for each different trust, which we then used to encrypt the data and then send it back using a secure FTP portal, eventually leading to the consultancy having these massive files of data that had different identifiers that allowed the data to be matched, but those identifiers were sufficiently delinked from the personal data that underlied them. So this was the approach that we ended up taking, and it turned out to be reasonably successful. We did a dummy run last month, and we got the results literally 2 days ago, so I'm very happy to be able to present the results to you, which is that we were able to successfully match most, if not all, of the synthetic data that we tried out in our dummy run, with the intention of taking this forward using real live data as well. So what have you learned? And where is the project actually headed? Well, the key takeaways that I'd like for you to be able to understand and really embed and imbibe is that data sharing has both legal and technological dimensions, as I've mentioned, and they need to be very seriously considered. You can't simply think that because we've anonymized the data and under GDPR anonymization is fine, we can just share the data. That's not enough. We should consider what anonymization techniques we've actually used. In a wide-ranging industry initiative, for example, the Pensions Data Project, do not necessarily expect every participant to be on the same page legally and technologically. Consider the need to procure common solutions if it's possible, but understand that you may need to resort to primitives in the cryptographic sense, as opposed to all of the fancy privacy-enhancing technologies that I was able to show you, like homomorphic encryption and like differential privacy, which may not necessarily be fit for purpose. And hence why not every privacy-enhancing technology is going to be useful in every situation. If you do have a choice of privacy-enhancing technologies, I do suggest the Center for Data Ethics and Innovation's PETS Adoption Guide. It was very, very useful, not only for us, but for many other organizations that intended to share data as well. And most importantly, anonymity is contextual. You need to consider what somebody who wants to de-anonymize the data set will do. And you need to think very, very laterally as well, because it could be the case that data in isolation may be anonymized, but you need to think about publicly available data sets and how they could be used to match. In terms of the next steps, the Pensions Data Project has completed the dummy run of the new setup, which established data matching is possible, and we're currently reviewing feasibility for larger data sets, hopefully with a view of sharing the entire books of all of the providers in the format that we've just described by the end of this year. And yeah, that's it. That is my short, but hopefully very enlightening and instructive presentation on anonymization techniques and anonymity and what we, the Pensions Data Project, were doing to tackle these issues. They say that repetition legitimizes, and I'm sure, and I've actually been to other sessions where they talked about privacy and anonymization. And in fact, in one other session by somebody from Google, they talked about the exact case study with Netflix that I talked about as well. So hopefully you were able to take something away from this, and I'm happy to answer any questions if you might have, or not. Thank you. Yeah. Cool. We have one question there.
I have two questions, actually.
Sorry, I can't.
Closer to the mic. I have two questions. Yep. One, did you hire a security consultant to check the use of cryptography and things like that? Mm-hmm. And the other question is, as you're going to scale the data set, do you expect more collisions? And did you make sure that the algorithm or the parameters you chose can be scaled when you don't use a dummy run with a small data set and you use a 10 times or 1,000 times larger data set?
Yep, that's true. And so we have, as part of the Pensions Data Project, gotten consultants involved. We've worked with a consultancy organization that's involved with not only the data matching aspect of it, but also the security aspect of it. It's just that because of the scale, we wanted to start off small and then figure out whether the techniques that we use were actually feasible, and then try to scale that up with even more synthetic data first, and then try to move on with live data. So because we understand that certain techniques, especially with statistical techniques like generalization, they may work in certain contexts, they might not work in other contexts. So it is definitely something that we have considered going forward. And I really do appreciate the question, because this is the kind of question that prompts us to really start thinking about all of these issues instead of resting on our laurels and thinking that we've done enough simply because I don't think that anyone can, de-anonymize the data set. So we are taking numerous approaches into consideration. It's just that because we're working with certain constraints on technology, we have to try to resort to whatever means we can to get us to as far as we need to. We did do a data protection impact assessment as part of the Pensions Data Project and sent that to the ICO, who came back basically approving of the techniques that we've used, because they mentioned these exact techniques in their anonymization guidance. So yes, but thank you for the question. Any other questions? We have one over there.
Hi. I saw that you mentioned that in addition to doing the hashing, you also generalized things like postcodes, and you gave the example of there might be one person on the Shetland Islands, so they'd be easy to single out in that data set. Before doing that, did you have any predefined thresholds that you wanted all segments or demographics to hit? So did you want it to be, I guess, any group had at least 5, 10, 3 people, or was it just sort of organic?
Yeah, so that's a question that we definitely did discuss. It's a question that we wanted to address a bit further down, because that's more to do with data scope and trying to find out what data we needed to then input into the systems, as opposed to the technology that we were using for the sharing in the first place. So it is something that we are going to be doing going forward, but right now the main point of this presentation was just to focus more on the technological approach to how we decided to anonymize the data set. But you are correct that scoping out the data and finding out whether, on the basis of the data that we've decided to share, if there are sufficiently enough examples, that would definitely be a key consideration, because we don't want there to be situations where under any cross-section you would be able to narrow down and find out an individual. And that's something we definitely have considered, and we definitely do want to avoid. So we have considered that. Thank you.
Hi. So I think before you started the anonymization process, you needed to find out the PII data in your data set, in the database. And also, once you chose the method of anonymization, have you used any technologies to help you with that discovery first, and also to anonymize a large data set and to make it automatic?
I'm sorry, could you repeat that question? I'm not able to hear.
Sorry, so I guess you had to do a discovery phase first to find out the PII data in your data source, the pension funds.
Yep.
And what technology have you used for that, or was that a manual process? And also, once you choose the anonymization method, have you used or considered using a technology to do that automatically, or did you anonymize the data manually?
Right. So for the discovery process, there wasn't really much, because we already knew what fields we would be using to try to match data sets. So it would be the name, national insurance number, and date of birth. And each of those 3 were the ones that went through this technique. In terms of the technology to use that, that's precisely the reason why we had to go slightly more primitive, is because we had budgetary constraints, we had time constraints, we had implementation constraints. If we had a bit more money, we would be able to try out newer techniques of anonymization, but because we didn't have the luxury of that, we had to try a different approach. And so we basically used functions that are very easy to implement across a different spectrum of programming languages or applications that you decide to use. So generating keyed hashes is something that you can do on any programming language if you want to. In fact, one thing that really surprised me is that you were able to do that on Excel as well. You can do SHA-256 on Excel. It's not exactly the best, but you can do that, although we strongly advised against it. So I take the security issue into account. But yeah, we weren't really able to because of the constraints that we had, but hopefully we were able to do the best with the constraints that we had. Yeah. One more question there, and I think that should be it. But yeah, it's in the middle there. Yes.
If you are in a position where you have to fuzzy match, like John F. Kennedy and John Kennedy and John Fitzgerald Kennedy, and then obviously once you apply your hash, they will be completely different. Yeah. Do you encounter such situations, and what do you do?
Yeah, so that the data quality issues that we've had with trying to match data sets has been unparalleled, because there have been situations where different names had different diacritics and accents on them. And so one of the things that we tried to do was try to standardize the data before we went through the anonymization process. So if, for example, a name had diacritics, or if they had hyphens or apostrophes and things like that, we needed to get rid of all of that, strip it all, and make it completely clean. And that's why we used 3 fields of PII to be able to try to match the individual. So national insurance number, name, and date of birth. And we consider 2 out of the 3 to be a reasonable match. If we get all 3, then it's a perfect match. And if we didn't get any more than 2, so if we get only 1, then we would consider that to be a completely separate individual. This is an ongoing problem that we have had, and to be honest, is something that we could use a little bit of guidance on. But hopefully should not be something that should prevent us from trying to match the majority of the data that we hold. Because in the dummy run that we tried out, there were only about 1% of cases where we weren't able to actually match the data that should have in fact been matched. So hopefully we were able to look at that as a bit of an acceptable risk rather than something that needs to impede us moving forward with the project. So yeah, I hope that answers the question. Thank you. All right. Well, in that case, thank you, everyone. If you have any further questions, once again, I will bring up the first slide, which has my email and my full name that you can find me on LinkedIn. There we go. Thank you, everyone.